1.5.1a. Which of the following expressions is equivalent to, on the top it has x to the 1/3 over x squared quantity to the 8th, and in the denominator it has the 6th root of x squared. And it says something about x is greater than 0. That's our domain. And the reason that they chose that domain is because if we have a negative inside of an even root, like the square root of a negative, for example, that's an imaginary number. There's also an issue with dividing by 0. That would be a big deal, right? First commandment of mathematics, thou shalt not divide by 0. So just to take care of those issues, they specified x is greater than 0. Alright, so in 1.5.1 it lists a lot of rules, a lot of algebra rules that you learned a long time ago that have to do with exponents and roots. And so let's take a look at 3 of these that you'll need for this problem. The first one that I've written in the box, algebra rules to remember, is that the nth root of a to the m in either order is a to the m over n. Just like with a tree, in real life, a tree does the best if the roots are on the bottom of the tree. So the root, the n, is on the bottom of the fraction. M, the power, is on the top, so that's a to the m over n. Now I'm going to apply that rule to our denominator. Our denominator is the 6th root of x squared. I'm going to rewrite that denominator as x to the 2 over 6. The 6 was the root, that's the denominator. And then I'm going to simplify the fraction. 2/6 is the same thing as 1/3. Alright, the second rule that I wrote down, a over b to the p. This was another rule that was listed in 1.5.1. I can distribute that power, the p, to the top and the bottom, so that's a to the p over b to the p. And I'm going to do that with our numerator in our problem. We have x to the 1/3 over x squared quantity to the 8th power. So I'm going to distribute that 8 to the top, making that x to the 8/3, and to the bottom, making that x to the 16. Alright, next I just put those back together again. The numerator I rewrote as x to the 8/3 over x to the 16, and the denominator I wrote our x to the 1/3. Alright, so now I'm going to apply another rule that was listed in 1.5.1, which was a to the p divided by a to the q is a to the p minus q. Alright, so I'm going to do that first to the numerator. I'm going to rewrite our numerator as x to the 8/3 minus 16. I left the denominator the same, x to the 1/3. Then I want to apply that rule again by subtracting the 1/3. So I have x to the 8/3 minus 16, and I rewrote our 16 as 48/3, so we'll have a common denominator. And then subtracted the 1/3 from our denominator of our fraction. Alright, so 8/3 minus 48/3 would be negative 40/3, minus one more third would be negative 41/3. And if we use, I didn't write it down, but if we use that rule that says if you have a negative exponent, you can drop that to the denominator and make it a positive exponent. I didn't write that rule down, but our answer is B. Choice B, which is 1 divided by x to the 41 over 3. All right, hope that helps out.